initialize recording. Okay, here we go. At what rate is the diameter increasing when the volume is 100 cubic centimeters? You don't need per second. So this is like a problem I gave you yesterday, but people were struggling with it, so I thought I'd add a little sheet of notes where we tried a couple more examples similar to it. What shape does a ball make? A sphere. So your formula should probably be the volume of a sphere. Good. Yeah, volume is 4/3 pi r cubed. What is our known? V prime is 10. What's our unknown? What is it that we're trying to find? D prime. The rate at which the diameter is increasing. So this is where something needs to kick in here, all right? And what needs to kick into your brain right now is that you're looking for D prime. When I currently take this derivative, will I come up with a D prime? No, I come up with an R and an R prime. So that's problematic for us. R is equal to 1/2 D. So therefore, I can now make a substitution. Take that, plug that right in for R. So volume is equal to 4/3 pi times 1/2 D to the third. Oh gosh, horrible drawing today. All right, so what is 1/2 to the third power? 1/8 times 4/3 would be 4/24, and 4/24 is the same as 1/6. So we got 1/6 pi D to the third power. Don't take the derivative when it's like that. You would have to use the chain rule. Make sure that you multiply it out and get this right here. Say it, Amber. Good question, because Amber now recognized that when you take the derivative, not only are you going to come up with a D prime, you will come up with a D as well. So we need to know D. That has to be a known. How can we come up with D? Stop. Use the 100, but use what you just created. Did we not just create a formula that instead of solving for R, we would actually be able to solve for D? So use that. Use 100 is equal to 1/6 pi times the diameter cubed. So multiply both sides by 6, divide by pi, cube root both sides. I believe you come up with around 6, 5.8, something like that. .75, so we'll go with 5.8. We'll go 7.5. Is that, you guys all right with that then? Do I now have enough information to do the rest of the problem? I do. So I will take the derivative with respect to, because they're all changing in accordance with time, of the volume, which is equal to now 1/6 pi times D cubed. What's the derivative of volume? V prime, or 10, yep, is equal to, bring the 3 in front, 1/2 pi times diameter squared, diameter prime. Very good. V prime, already said 10 is equal to 1/2 pi times 5.75 squared times D prime. Multiply by 2, divide by pi, divide by 5.75 quantity squared. Somebody tell me what you get. Should be around like 0.2, I'm guessing. 0.19. What is our label? Centimeters. We leave it to the first dimension or first degree because diameter is a one-dimensional piece, right? If it was area, it would be squared. If it was volume, it would be cubed. So diameter is a single dimension, so therefore it's centimeters of first power. Over, what's time? Second. Okay, back to Megan's question. Megan, you're wondering how we got 5.75? You see how we get this equation right here. I wrote a formula that said volume is equal to 1/6 pi d cubed. I got that because I substituted the r is equal to 1/2 d in for r. That gave me this equation right here. So it says, at what rate is the diameter increasing when the volume is 100? I could either put 100 in this top equation or into this one. I like this one better because it's already solved for d. Or it contains d. So I just multiplied by 6, I divided by pi, and I cubed root both sides, and I got 5.65. Better? Okay. I promise you're going to have to do a problem like that come time for your test. Next one. Corn is being emptied. Again, don't have enough corn. I heard the price of corn went down this year. We empty the corn and makes a pile that's the shape of the cone. 12 feet per minute. 12 cubic feet per minute is what is being piled up at a rate of. Check. Take it on when we get back. So we've got an auger with corn. It's piling corn at a rate of 12 cubic feet per minute. It's taking the shape of this cone. How fast is the height of the pile increasing when the pile is 6 feet high and the base diameter is 8 feet? So we currently have a height of 6 and a base diameter of 8. What formula do I need? Okay, this is critical. There's so much. We did not do this exact same problem. The problem we did said that the radius was the same as the height. The substitution was simple. This one requires a little bit more of a geometric argument in order to make it work out. So we're going to have some knowns and unknowns. Number one, what is the unknown that we're looking for? H prime. Okay, so follow me here, everybody. This is the really important part. When I take that derivative right now, what rule will I have to use? The product rule. So will you come up with an H prime? Yes, that's what we're looking for. Will you come up with an H? Yes, do we know H? It's 6. Okay, will you come up with an R? You know R. R is 4. Will you come up with an R prime? You know R prime. No. Do we have any way of finding R prime? No. So therefore, we may not leave the equation like that. Since you don't have an R prime, we use a little foresight at this point to realize, oh no, we've got a problem. If we were given R prime, then we could go ahead and use the product rule. But so we're going to have to make a substitution. We have to get rid of that R because we want H. If it was asking for R prime, we would get rid of the H and have an R in there. So we are going to take the shape of this figure and we are going to create a proportion. This cone will continue to grow with the height and the radius having the same proportion, okay? Same ratio. So the radius currently is what? 4 over 6. So radius over height is equal to 2 over 3. Multiply both sides. R is 2/3 height. Why did I solve in terms of H again? So we're looking for H prime. If I was looking for R prime, instead of R equals 2/3 H, I would use 3/2 R is equal to H. You see that? So you have to decide which one you want based on what you're trying to figure out in the problem. So my knowns in this situation, we're going to use the fact that R is equal to 2/3 H. I took my drawing and I made that relationship. So that was nice. It says how fast is the height of the pile increasing? So what else? We have the volume prime. V prime is 12. And we know that the current height is 6. We know the current radius is 4, but we don't even need that. So I'm going to have to switch this equation so that I only have h and not r. So I'm going to take my 2/3 h, I'm going to plug it in for r. Therefore, I have volume is equal to 1 over 3 pi times 2 over 3 h, quantity squared h. Some people will leave it like this. Don't leave it like that. Again, now would require the use of the chain rule and the product rule, which you don't want to use right now. Multiply it out. What is 2/3 squared? 4/9 times 1 over 3, 4 over 27. So the volume is equal to 4 over 27 pi times h squared times h would be h cubed. Do you have what you need now? So we'll take the derivative with respect to time of the volume, which is equal to 4 over 27 pi h cubed. What's the derivative of volume? V prime is equal to, drop 3 in front, that will simplify to 12 over 27 or 4/9 pi h squared h prime. That's my derivative. Plug in the knowns and unknowns. 12 is equal to 4 over 9 pi times 6 squared h prime. 6 squared is 36, divided by 9 is 4, times 4 is 16, so 12 equals 16 pi h prime. Divide by 16, and by pi, I get 3 over 4 pi is equal to h prime. Or h prime is equal to 3 over 4 pi. What is my label? Feet. It is a rate, so I have to have per minute. But I didn't actually do the problem, did I? Oh, I did? I'm sorry, you guys. If this was very similar to the one yesterday, I didn't do this problem for second hour, and so they were a little bit more confused when they got to the assignment. But it doesn't hurt you to see it again, does it? Okay. All right. One more on the back. This is a classic problem. A street light is mounted at the top of a 20-foot tall pole. Man 5 feet tall walks away from the pole with a speed of 4 feet per second along a straight path. How fast is the tip of his shadow moving when he's 30 feet from the pole? I have my pole. I have this man. He's got a really long neck. Again, you don't have to draw the 4 boxes. I just like to organize my work that way. Again, I'm not responsible just for my learning. I'm responsible for all of yours. And so staying organized seems to be helpful. Oh, I did. Oh. Okay, everybody. Yes. Okay. So this is 20, and this is 5. This is 30, and we don't know this. Okay. This is a great example because it helps you understand how you set some of these problems up and what some of the tricks of the trade are. For example, sometimes people set this problem up incorrectly because they use the 30 right away. Question. Just to the man. Yep. So it says that he is 30 feet away from the pole. You see the two triangles. Okay. Now, hold on, because every time you do a related rates problem, you should always think through some of these things. Okay? First of all, does this 20 change? No. Does this 5 change? No. Does this 30 change? Yes. He is walking away. So this does change as he walks, doesn't it? So I cannot simply just use 30. I must use a variable. What variable would you like to use? Well, D for distance. Does the length of his shadow change? Yes. As he walks further away, the shadow will get longer. Okay? Think about it. If he was standing right up next to the light pole, would he have a shadow? Hardly at all. Whatever that distance that he would be standing away from the light pole, it would be a tiny little shadow. The further he walks away, the longer this is going to get. Okay? We could plug in different numbers. We could even set up a proportion to figure it out, couldn't we? 20 over 5 equals 30 plus that over that. Okay, and we can figure out what those lengths would be. We can see they would get larger. But what we need here is we need a formula that's going to tie this all together. And when you think of formula, so often you're thinking of something that is written down in a book. But this is nothing that generally is ever written down. This is one we're just going to come up with on our own. So I've already given you a hint. We're going to call this length S for shadow. Two kinds of people in this world, Emerald. High maintenance and low maintenance. Okay. All right. I thought I could choose any letter in the alphabet, but apparently not. All right. Okay, somebody give me a formula here. Give you a hint. Very good. If you would take the derivative right now, you would need to use the quotient rule or the chain rule. I don't want to do that, so let's just cross multiply. 5d plus 5w is equal to 20w, or 5d is equal to 15w. That's a formula that I can now use. When I take the derivative of 5d, what do you get? 5d prime. So do you need to know d? D has no bearing on the problem at all. Do you need to know d prime? Yes. Do we know d prime? So he's walking away from the pole with a speed of 4 feet per second. So our knowns, d prime is equal to 4. We know d is equal to 30, but we don't need it. What is the unknown we're looking for? Close, but we'll write it as w prime. You'll find out how it looks in the end. Do we actually need to know w? No. If we did need to know it, we could figure it out by setting up a proportion, figuring it out. So let's take the derivative with respect to time of 5d is equal to 15w. What's the derivative of 5d? 5d prime is equal to 15w prime. So we'll just plug in our values. 5 times what's d prime? 4 is equal to 15 W prime. 20 is equal to 15 W prime, or 4 over 3 is equal to W prime. But we have to answer the question. The question is, how fast is the tip of his shadow moving when he is 30 feet away from the pole? And 4/3 is not the correct answer. What does 4/3 represent? It is a rate. It's the rate at which his shadow, the tip of his shadow, is moving away from him. But he is moving. Okay, so let's suppose that Emerald is at the airport. She's waiting for Amber to fly back from Tennessee. And as she's at the airport, lo and behold, Mr. Gantz is getting on a plane to Moscow. He's going to go visit Putin. And thank you. So there I am. I am going to get on those, those escalators that they have where you can walk faster, like those moving sidewalks. Okay, so let's say I'm walking at 2 feet per second. Okay. If I'm walking just across the airport at 2 feet per second, I wave to Emerald, who's waiting for Amber. Relative to Emerald, I'm moving at 2 feet per second. Suppose instead of walking across these a normal part of the airport, I get on one of these moving sidewalks. Let's suppose that the moving sidewalk moves at a rate of 5 feet per second, and I'm also walking at 2 feet per second. Relative to Emerald, I am moving at 7 feet per second. Relative to the moving sidewalk, I am moving at just 2 feet per second. So when you see this, the tip of the shadow is moving 4/3 feet per second away from the man. But the man is also moving at what rate? 4. So the answer is 4 plus 4 over 3, or 16/3 feet per second. Does that make sense? All right. So please look in your assignment. Okay. I have the answer key right up here. It has all the problems. Oh, I guess we found where Miss Sarah put all the notes. What a smart little girl she is. Okay, questions 1 through 6. Those are non-negotiable. You need to know how to do every single one of those, or this test will be hard. It will not go well for you. Okay. Second of all, I gave you yesterday, I told you work on 7, 8, 9, correct? Those can be challenging. You really need to work hard on those and make sure that you understand this answer key and how you come up with those, because you will have problems like that on the test. I also gave you 10, 11, 12. Those weren't quite as difficult, but they are a little bit involved. Go to the level 3. Today, I assigned to you problem 14. You also have problem 16, which I gave to you the other day. You also have problem 18, which I gave to you the other day. So I have assigned the evens of level 3. Here's what you need to do in addition to that. So I give you 14 today. You also need to do at least two additional problems. Okay? From level 3 or 4. So last year I had a student, and it was not the top student in the class, and they said, I am going to figure out how to do all the problems. So I'm ready for this test. They did all 1 through 22. Now they didn't ace the test, but they were close to acing the test. Some of these, yes. But some of these problems are very challenging. I'm going to do one more problem for you tomorrow that models one of these really difficult ones, okay? But otherwise, you need to get control of your homework. Make sure you can figure this stuff out and come in and see me because on Tuesday you have an open note test on this in class. Got it? Are we good to go? Go to work.